Cloud bills have a way of sneaking up on you. You start with a small project, a simple machine learning model, and you sign up for a managed droplet because the interface is familiar. You pay a premium for the convenience. But as your training loops get longer and your data sets grow larger, that monthly invoice starts to look less like a subscription and more like a tax on your growth. You find yourself asking if there is a better way to handle the raw compute power required for modern artificial intelligence without bleeding budget. This is where the conversation often shifts from convenience to cost-performance ratios, and that is where the path from DigitalOcean to Hetzner becomes interesting. Here is the thing about cloud infrastructure. Managed services like DigitalOcean droplets are designed to abstract away the complexity. You spin up a server, and the provider handles the underlying virtualization, networking, and often the storage optimization. It is like renting a fully furnished apartment. You can move in immediately, the lights work, and the landlord fixes the plumbing. However, for heavy machine learning workloads, you are paying for that convenience. You are paying for the overhead of the virtualization layer that sits between your code and the actual silicon. When you switch to a provider like Hetzner, you are often moving to raw, dedicated hardware. This is the difference between renting an apartment and buying a house where you have full control over the foundation. The cost difference is the primary driver for this migration. Hetzner generally offers significantly lower costs for comparable or superior hardware specifications. In the context of machine learning, this often means access to better graphics processing units or tensor processing units for the same monthly price. A graphics processing unit is a specialized processor designed to handle parallel processing tasks, which is exactly what neural networks need during training. On a managed droplet, the performance of these units can be throttled by the virtualization layer. On dedicated hardware, you get the full bandwidth of the card. This translates directly to faster training loops and the ability to run larger models without hitting memory walls. However, raw power comes with a price in terms of operational friction. You are no longer in a fully managed environment. This becomes critical when you consider cold start latency. Cold start latency refers to the time it takes for a server to become fully operational and ready to accept requests after being powered down or provisioned. In a managed cloud, this process is highly automated. You request a machine, and it is ready in minutes. On dedicated hardware, the provisioning process can vary depending on the specific rack and the physical state of the server. If you are running continuous training jobs, this latency is negligible. But if you are using spot instances or spinning up machines on demand to handle bursts of training, the wait time can be longer. You have to plan for this downtime in your workflow. The migration process itself is not without its own specific technical hurdles. While theoretical frameworks for live migration exist in the academic literature, the practical reality of moving from a virtualized environment to bare metal often reveals gaps in compatibility. For example, there are documented instances where booting rescue media via kexec fails on the new hardware. Kexec is a way to boot a new kernel from the currently running kernel without going through the system firmware. On DigitalOcean, this is handled smoothly by the platform. On Hetzner, the interaction between the rescue media and the kexec system can hang, requiring manual intervention. This is a knowledge gap that many practitioners face. You cannot simply script a one-click migration and expect the operating system to boot correctly on the new bare metal hardware without checking the boot configuration. Because of these friction points, the community has converged on a specific strategy for moving workloads. A successful migration typically involves a hybrid approach, where critical services are moved incrementally rather than all at once. You do not rip and replace your entire infrastructure in a single weekend. Instead, you leverage the flexibility of the new provider's application programming interface alongside the familiar workflows of your current setup. You might keep your development environment on the managed cloud while moving your heavy training jobs to the dedicated hardware. This allows you to test the new environment without risking your core operations. It also gives you time to resolve any boot time errors or configuration mismatches that arise from the kexec issue mentioned earlier. This shift highlights a broader trend in the developer community. There is a growing movement of engineers seeking cost efficiency by moving from high-overhead managed clouds to cheaper bare metal providers. They are accepting increased operational responsibility in exchange for raw compute power. It is a trade-off between your time and your money. If you have the engineering bandwidth to manage the operating system, the network configuration, and the recovery procedures, the dedicated hardware offers a performance-to-price ratio that managed droplets simply cannot match. The learning curve is steeper, and the initial transition involves more potential downtime, but the long-term performance and price-to-performance ratio result in a highly positive user experience for those willing to do the work. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.